Hello guys, so let's get started in some theoretical classes just for us to understand where Snowflake fits actually. So that's why I built this diagram here just to tell you how is a modern data platform structured. Okay, I mean this is very generic and could also fit not in a modern data platform, let's say a platform that doesn't use modern data stack, which Snowflake belongs to, but it kind of comprehends everything that we need to understand and all the steps, all the stages of the data lifecycle in a data platform. Okay, so yep, let's get started here in the left where we have sources. So that's known by everyone that we are producing a huge amount of data on a daily basis, and it comes from a huge variety of sources. So we can say that, for example, we get data from devices, from web pages, from searches in web pages, from tablets and other modern devices, and social networks also. Here we have a common example of a streaming source that's very common also, especially among the company. So in between your company's areas, it's very common to use Kafka to transport data from one area to the other. And databases are also very common inside. Actually, this is one of the most common data sources for data platforms because, for example, your ERP systems, your CRM systems, they also have their own databases, and then you can directly consume data from their databases, right? You can also consume files from areas from different sectors of the company. These files can come from FTP servers. They can come already directly in a blob storage, which is, let's say, object-oriented storage inside a cloud provider, and also HTTP requests. We can say that also APIs. APIs is a very common way to either ingest data and to deliver data. It's very common also as much as using Kafka, but I think it's even more common is to deliver data. Even data engineers do this job of delivering data to other areas of the company and especially to other systems of the company through APIs. So you build an API that fetch data on the top of your database. It could be Snowflake, for example, and then you deliver the expected data, for example. That's a very common way, okay? And moving from the sources, we enter then in this bigger box here. Why this bigger box is separate from the sources is just to illustrate that most of the times the data you're ingesting, they are still not part of your current data platform. So usually they come from outside, other accounts, or even other systems, okay? And then to fetch the data, to ingest the data from the data sources, what we use ingestion tools. It could be dedicated ingestion tools, like for example here, I illustrated that with Airbyte, with Data Factory, but we also have other tools available in the market. You can build your own code to do that, but we have also Fivetran is a very common tool to do this kind of data ingestion. So they're easy to use, and then they do a kind of a copy one by one. They have special features to help you not copy duplicated data. So they are focused on ingestion, but you can also build your own code. And then with that, you can ingest data from Kafka, from Kinesis, which will be the streaming version of Kafka in AWS. You can also use Event Hub or PubSub. They are basically publisher subscriber streaming tools, simplified streaming tools to help you ingest data in real time. You can also write a Glue job, a Spark job to run in Glue and ingest this data. So it's a huge variety of ways. And I put Snowflake here because I want to let you know that you can do some sort of ingestion data with Snowflake, okay? And then once the data is ingested, we go to a transformation phase. This transformation phase can happen either in a database, on an object-oriented storage, such as S3, GCS, Google Cloud Storage, Azure Blob Storage, and also in databases Snowflake. I didn't represent ideally like a storage platform here, because it really depends, but we assume that since we are a data platform, we are storing the data somewhere, so this should be kind of not needed to explain, right? And then we do the transformation phase on it. You can do that transformation phase very commonly done in SQL, very commonly done in Spark, especially for a huge amount of data. Spark is very good for that. You can use then Scala Spark or Python inside Databricks. You can you have the help of dbt with Databricks to help you out on sorting your data structures, but you can also do all of this inside Snowflake. So Snowflake is also very good for transformation, and especially because it's really fast. It's a columnar oriented storage. It has its own engine and way to manage your clusters in a very nice and easy way. We gonna cover that. So I want to show you that you can use Snowflake to do transformations either with SQL, or you can do your transformations either with Python or Spark through a new feature, not so new anymore, but is still in development, a feature called Snowpark. You use a Snowpark SDK to run Python, Spark, and Scala jobs inside Snowflake with its Snowflake engine. That's pretty amazing. And I would say even better is being able to process data, transform data, huge amount of data with Snowflake using SQL. So I think this is a very nice way to go. And adding dbt with Snowflake, you create a very robust solution, because dbt then adds your tracking lineage for the data. You can add tests, you can version your queries through a repository through GitLab, GitHub, okay? And after this transformation, then we go to the delivery phase. Delivery phase is basically model data that you can deliver either in a database. Here I just showed pictures of icons of databases like Redshift, Snowflake, Synapse Analytics, and let's say a SQL Server, for example. It could be an Oracle database also. But you can also deliver data. If you have a lakehouse structure, you will also be able to deliver data directly in files. But my personal opinion is that regular databases, relational databases, they're much easier for you to model the data, to understand the data than having files, and also to manage the objects. Especially security and data governance are much better done through all these features, and through Snowflake as well. It's pretty easy and good. And then this data after modeled the way you need, the way you want, data vault, normalization model, dimensional model, whatever, you deliver that for consumption. Okay, then another database can consume it, because you can be a source system for other systems. And of course, the traditional dashboard and BI tools, and even for data science cases. All right, and a bit of a spoiler, data science cases can also run within Snowflake, running Python code using the same Snowpark API. Okay, and just to finish, we have some other lifecycle objects. Here I draw them as a separate box, because they can be either within or not your platform. They can be external tools that you can attach to your platform, and we're gonna see which of these lifecycle objects Snowflake can help you out. And then you can consider that they are in this box, so they are within the same data platform, which easy your life. Okay, Snowflake has a very good tables and logging and metadata tables. It's huge. Every operation that you do in Snowflake, it's logged in some of the metadata tables. This is really amazing. Okay, data reconciliation is basically the means that you use to transform your data and then to curate it and to deliver it. So of course, Snowflake helps a lot in that. Security is a huge feature of Snowflake, and we're gonna see some of the basic roles assigned to Snowflake and which are they are supposed to do, but also, yeah, on top of that, you can build your own customized role-based access control, which is really interesting. Okay, we're not gonna cover a creation of a full RBAC, but just to let you know that you are, of course, able to do that. Snowflake can be easily integrated with DataOps. So for example, you can use a Snowflake client to automate your processes. You can use Terraform to automate your process, and then everything can run through ops tool, for example, like GitLab, as I illustrated here, but could be GitHub Actions, could be Gitbucket, or whatever you want to use, DevOps, Azure DevOps. Okay, it's really easy to integrate that. Data cataloging is something that's coming up. One remark more, DataOps, Snowflake is building in the future, it was already announced, direct integration with Git. So you won't need to integrate that by yourself, build your runner, build your client integration, it's gonna be automatically integrated. So that's gonna easy our life so much. And then cataloging also, Snowflake is delivering soon. I don't know actually how much soon, but they already announced they are working in better cataloging visualization tools, because today through the metadata table, you can find all your lineage, everything you might need to know about your data and how they move in between the tables, but you need to query through the metadata tables. So they are using these metadata tables to build nicer visualizations to help you out. Tagging is already available, so it's very important for data catalog is to have your data in your data objects tagged, and then this is already available, right? And orchestration. Orchestration I illustrated here as Airflow because it's one of the most common and is easy to integrate, also to run with Snowflake. But for simple scenarios, you can create complex dependencies. Simple scenarios, I mean, within Snowflake objects, you can create complex task DAGs, and this we're gonna cover here in the course, okay? And I'm gonna let you know how to create tasks and create task dependencies and how to see the DAGs and monitor them, okay? So I guess this is all for this class.